Okay, welcome, folks. We are about to talk about retrocommissioning, especially in the HVAC sector. We've got Jeremy Blanchard from GDS Associates that will be doing our presentation. We're going to have a Q&A session that will happen at the end of the presentation. So there is a little button to press on the bottom of your screens that will allow you to put in questions throughout the presentation, and we will hold off answering them until the end. But we look forward to a great presentation and kick it over to Jeremy.
Thank you, Matt. Just a heads up, everybody, I'm feeling a little under the weather, so uh, pardon me if I take a break to sneeze or whatnot. Um, so without further ado, our agenda today in talking about retrocommissioning, we want to start with just a high-level overview of strategic partnerships and opportunity and how the NHSaves utility program and partners can help drive energy efficiency projects at your facilities or your customers' facilities. We want to start with a controls overview and just set the stage for what retrocommissioning is, how it works, how it impacts your energy management or BMS or control system. And then lastly, we'll go through a couple of case studies, project examples highlighting how the NHSaves program helped partner with TA vendors, controls contractors, and customers to support energy efficiency projects. So benefits of the utility strategic partnership is it allows a multifaceted approach to integrating solutions in the C&I customer space. Allows resources to be brought in, and we'll talk about those later on in the presentation. And expertise. You know, you as a building owner or you as a vendor may have a great relationship with your customer, but may not have the expertise or know who to point to do a deep dive into a control system. And that's where the program can help support you with bringing expertise and resources to your facility. And then lastly, if not most importantly, for some customers is the incentives, the ability to provide funding to offset the cost of those projects to make them even more financially attractive and able to implement those projects. At the end of the day, the NHSaves program's goal is to drive energy efficiency projects to completion and generate claimed savings for the program. So opportunities with EMS. I like to say that EMS or energy management system is the new lighting in many ways. It's cost effective, prevalent energy savings opportunities, um, and it can be a very low hanging fruit, low payback opportunity. Often underutilized. You know, we go into a lot of facilities and many control systems are outdated. They have old controls, proprietary networks, just lots of opportunity for not only upgrading the control system and providing energy management, but also operations benefits. You know, the more you can measure, the more you can manage and the better your systems can be. There's potential opportunities in new construction applications. I like to joke that I can go into a brand new building that was just built yesterday and probably still find a few controls opportunities. You know, won't be as much, but there's always opportunities to push the envelope and optimize and get more energy savings. You can look at new systems that don't have any existing control system. Or you can look at existing buildings and existing control systems, and there's a whole plethora of what you can look at from complete replacement to component replacement, add-ons, integration, software upgrades, and so forth. One note to make is that in order to qualify for an incentive, you really have to implement energy efficiency sequences or make changes that result in energy efficiency sequences. So simply doing a software upgrade oftentimes would not result in energy efficiency. However, if you're doing a software upgrade, no better time than to layer on energy efficiency. Since you're already spending money, you're already engaging your controls contractor, it can be a really good opportunity to make energy efficiency upgrades at the same time. To set the stage for controls, there's a lot going on in control systems here. We show a typical network architecture, and there's just lots of pieces, parts, and different networks. So we want to start with a breakdown of the overall architecture. I like to break this down into four major components. and do a sort of a bottoms up approach, starting at the end device, if you will, or the sensors. So the lowest level of a BMS architecture is the sensor or actuator level. This is where you're going to have sensors in the space, such as a room temperature sensor or a relative humidity sensor that provides feedback to, say, a VAV box, where the VAV box is going to modulate the damper and or reheat to maintain that space temperature that's being measured with that sensor. Moving up a layer, you get to the equipment or field controller level. There's typically one controller per major piece of equipment. So, for example, on a VAV box, there's going to be a VAV controller mounted right to the box that usually also has an integrated damper modulation. And that is the controller, the brains of that piece of equipment. You can have another controller on a chiller or an air handler or a boiler. And those controllers at the field level can operate standalone. You can disconnect them from the two levels above, and they will operate just fine. Now, sometimes when that happens, schedules will get overridden or default to 24/7. Some of the energy efficiency sequences will not occur because those are driven from the integration level. But generally speaking, the brains of the system is at the field and equipment controller level. That's where a lot of the programming exists and control of the equipment. Now, at the integration level is where all of those equipment controllers get integrated to a common platform. And now you can have programming, universal programming, such as schedules for the overall building that get driven down from the integration level. And um, again, if the network, if you will, from the equipment controller to the supervisory controller is severed, then it would default back to whatever's on the controller, the equipment controller itself. But think of the supervisory controller as the main brain that sits on top of all the equipment controllers and maintains a common platform. At this level, communication is really important. You'll see that the graphic has the word proprietary in there, as well as BACnet. So BACnet is an open communication protocol that you can think of as like the language that we speak. We all speak English. Proprietary, you could think of as a foreign language that you may not be familiar with. That language is talked between the supervisory controller and the equipment controllers. And there's a lot of discussion in the market about open systems. And one thing I want to stress, I'm not going to go into it in too much detail, is that there's no such thing as a fully open system. Even if you have BACnet and all of your equipment is talking English, well, the reality is you could have different manufacturers or different people that are in your building, and you can't just change out the people or the equipment. So, for example, if you have manufacturer A for all of your equipment controllers, and you don't like the company that supports the manufacturer A, you can't necessarily just switch to manufacturer B without any costs. There's usually going to be costs associated with it. The degree to those costs can vary from manufacturer to manufacturer and from system type to system type. And I would say just reach out if you have sort of further questions on that. Don't want to go too far into the weeds on this. And then lastly, the highest level, the management level, is where you really integrate into a server platform or a web-based application. That physical supervisory controller connects to the internet, to the network, to the building's network, and allows you to have graphical interface, computer workstation, allows you to collect trends at a supervisor or server level. Some facilities will actually have to have a physical server in order to store the amount of trends necessary. Really quick, want to touch on the basic components of an EMS, software inputs and outputs. We'll touch on menu structure. We'll touch on a little bit. Graphics will show a whole host of those. Schedules, trending, and alarms. Just want to highlight that those are a major component of EMS. We're not going to dig into those too much. But just know that if you have a modernized, fully functioning control system, you really should be able to easily manipulate your schedules for all your equipment. You should be able to enable trending for all points with relative ease. And you should be able to have alarms for major systems like freeze stats and other issues that should pop up and cause attention from a maintenance and operations standpoint. So I'm going to focus on a couple of these, one being the inputs and outputs. This is a really important aspect of a controls because you really got to know when you're looking at a point, you've got to know whether this is an input to the controller or an output from the controller. So, for example, a fan status point is an input into the controller. It is a status that says it's typically a CT around the wire that measures current, and it tells the control system that, yes, this fan is either on or off, as opposed to a fan speed, which is oftentimes an output from the control system. It's telling the fan to go at a certain speed. Now, that doesn't mean that that's the actual speed the fan is at. That fan could be overridden at the VFD. The VFD could be in bypass. There could be a whole host of things that are going on. So it's really important to understand the difference between inputs and outputs. So again, inputs are from a sensor going into the controller. So it's the input to the controller. Outputs are signals going from the controller to either a relay, a motor starter, actuator, etc. And then you have software points. Those are just calculated points, such as a set point or an alarm or other non-physical calculation points. So here's an example I like to highlight of an actual controller graphic where you've got all the inputs on the left-hand side and all the outputs on the right-hand side. And you can see that there's fan status points on the left on the inputs, and on the output side there's damper actuators and fan start stops or command points. So just really just want to highlight the physical nature of a control system. So next time you're opening up a panel in a controller, take a look at what the inputs and output points are. So really quick, I want to breeze through some graphics just to show a mix of what's out there. There's a whole host of different manufacturers and different graphic types. Each control system will have its own menu structure. So you can see on this particular um, front end, they've got their menu structure across the tops with graphics, schedules, alarms, and so forth. Um, and on this different manufacturer, they've got their menus on the left-hand side. This one shows an example of a single building where they've highlighted their major systems on the bottom with all the rooftops units. And then they've got some miscellaneous equipment on the left and floor plans on the right. So here's an example of a fairly antiquated control systems floor plans where they show that the rooms, you can click on each of the blue and yellow boxes and it'll bring you to a fan powered unit or a VAV box. But here's a more modern floor plan where they've got thermographics, which are color coded colors of each space to show you whether the room is satisfied or if it's in cooling or if it's in heating. Can provide a nice visual of where you're going to likely have hot or cold spots. Here's an example of an antiquated rooftop unit graphic. No animations, pretty choppy graphics. Still can work, just not as modernized. As opposed to a very modern graphic here where you've got animation. So if that fan is on, you'll see the fan spinning, as well as lots more information is being provided. You're getting a lot more points. You're getting different sequences shown oftentimes. So you can see here there's a discharge air set point at 20 degrees outside air and 60-degree outside air. So that tells you they've got a supply air reset schedule, perhaps. It may not actually work, but it visually shows here that there's a good chance that they have a supply air or discharge air reset sequence. So these graphics can be very helpful for diagnosing what opportunities are available. Here's a more complex hot deck, cold deck unit. Not going to dive into that too much, just continuing to show different opportunities. Here's one of the more complicated air handlers out there, which is an OR operating room air handler. Lots going on in those spaces. And chiller plants. This is a two chiller, water-cooled chiller plant. Looks like it also has a water side economizer. And that's the chilled water side on this graphic. And then here's the condenser water side as well. Here's an example of a boiler plant. The pretty modern graphic on this one. So again, lots of points. You can see the pumps, you can see the differential pressures, set points, everything. A lot to garner from these graphics. Now switching to the terminal units. So this is an example of the antiquated fan-powered box that went with the floor plan and the rooftop unit I showed previously. Again, this has actually got a lot of the information that you would expect to see for a terminal unit, just not as pretty graphics. Whereas this example of a modern VAV box, you've got more modernized graphics as well as you've got trend data, you've got your zone temperature bars at the bottom for occupied and unoccupied. Just a lot more data and information is available. And then there's an example of an IR heater graphic on the right-hand side here. Um, Graphics, equipment summaries. I can't stress this enough. Both from an operations as well as an energy standpoint, if you've got a lot of terminal units in your building, be it VAV boxes, fan powered boxes, anything with a damper or a fan or a coil, strongly recommend having equipment summary pages. They often don't come by default from the controls company because they do require more effort to build and put together, but they can be incredibly beneficial because it allows you to see what's going on with all of those terminal units on one page or multiple pages, and you don't have to click through each individual floor plan. So, for example, you can see, in the middle of winter, are you doing a ton of reheating? And more importantly, in the middle of the summer, are you doing a ton of cooling and then reheating? Allows you to get a glimpse of what's going on very quickly. So, strongly recommend encouraging those to be included in projects, not only from an energy standpoint, but from a operations and maintenance standpoint. Here's an example of a lab hood, so just another system type. Here's a solar thermal hot water system, so a neat little graphic for that one. Here's a rainwater collection system. Worked on a project that put one of those in. It was pretty interesting. So they were gathering, basically how much rainwater was collected and how effective is that system, so it can provide a lot of feedback to you. So along those lines, metering. You can integrate electric, natural gas, really any metering into a control system, and it can be used to collect data, to visualize that data, provide reports. There's a lot of power available in a control system when it comes to integrating metering, trend data, and so forth, and reporting. So with that, we're going to move to retrocommissioning. So what exactly is retrocommissioning? I like to think about it as the systematic process of assessing and improving sequences of operation. Systematic in the sense that you want to go system by system and look holistically and improve. Oftentimes, people will just focus on the original design intent. This building was a lab and manufacturing space, and we're just going to keep the air handlers and the systems, meeting the original sequences that were designed 20 years ago. Well, oftentimes building spaces change, and they don't need the same airflows and the same air changes per hour and other aspects that they needed 20 years ago. So you really need to think about what should the design intent today be and build those sequences to meet the current design intent. Um, Retrocommissioning may include identifying and repairing hardware deficiencies, right? Putting together a deficiencies list. You look at the air handler and you open it up the panel, and all of a sudden the outside air damper actuator is hanging in the duct, right? It's not connected. Well, clearly that's not going to be able to modulate the outside air damper. So you've got not only inefficiencies, but you've got issues with hardware. You want to ensure systems operate efficiently and optimize. One thing that's important is never let energy sacrifice operations and maintenance, because if you do, it'll just get overridden. There should be a marriage between implementing sequences that save energy, but also make sense operationally. If you've got old equipment, you can't necessarily go in and put all these fancy sequences on that old equipment because you might be putting lipstick on a pig. And when that happens, things get overridden and it gives sort of retro commissioning and controls improvements a bad rap. So you really want to think about, the performance of the systems, the existing conditions, and understand, what works in the building and what doesn't. Scope should include reviewing set points and temperature resets, confirming outside air rates, looking at hardware functional testing, Again, developing deficiencies list and looking at sequences. So I'm going to flash a few sequence opportunities on the screen. You can get these from the presentation later on, so we're not going to go through these. But on air side, there's a whole litany of typical sequences from, outside air optimization to demand control, ventilation, et cetera. On chilled water side, chill water reset, condenser water reset, pretty popular. Water side economizer optimization, a whole lots of opportunity around chilled water systems. Hot water systems tend to be a little fewer opportunities there, but there's still, boiler staging, variable speed hot water flow. Variable primary is one of my favorites. Just slow pumps down if they don't need to. If the flow exceeds the boiler's minimum flows, just slow the pumps down. Common retrocommissioning targets. So these aren't necessarily sequences. They're more issues that you'd be looking for. So simultaneous heating and cooling, one of my favorites. You've got a VAV air handler providing 55 degrees all day long, 365, and it'll work just fine because the downstream reheats will just reheat the air whenever the space is getting overcooled. But it's massively energy inefficient. And putting in a nice supply air temperature reset sequence, ideally based on heating and cooling demand is ideal, and not just looking at sort of broad stroke outside air resets, but really driving to the load and what impacts that sequence is really important. Overridden VFDs, see those all the time. No temperature setbacks, poorly located or failed sensors. Really important to understand that the sensors and equipment is working properly. One of my mantras is don't trust the graphics. Just because it shows you a supply air temperature of X, don't believe it. Go measure, go verify, because oftentimes the sensors are wrong. I've seen sensors miswired. Just wanted to show a sequence example just to give you a flavor for what they sort of look like. So here is a supply air temperature reset. So the controller is going to modulate the supply air temperature based on zone cooling and heating requirements. Um, the supply air is going to start at 55, and as the cooling demand increases, it's going to reset that air a little cooler. As the cooling demand decreases, it's going to raise that temperature up to 72, which would basically minimize, if not eliminate, reheat. And then the same on the heating side. We'd be remiss if we didn't just mention monitoring-based commissioning quickly. Not the focus of today's discussion. The focus really is retro-commissioning, which is, I like to think, what should be done first. You want to retro-commission a control system to get it modernized, get it up to snuff, get it operating efficiently. And then once you've got a fully modernized, well-functioning control system, then you can look at monitoring-based commissioning, which is ongoing leveraging trend data to continuously monitor and identify opportunities, fault detection and diagnostics, finding issues based on data. But you really need to have a modernized, well-functioning control system. Communication is a big deal. You can have a nice, fancy front end with modernized graphics, but if what's behind those graphics is a bunch of old, antiquated, proprietary communications or even like pneumatic systems, then you're just simply putting lipstick on a pig if you're going to go in and put in monitoring-based commissioning, because you really got to make sure those end devices are working and functioning properly before you can necessarily implement monitoring-based commissioning or even retro-commissioning in that case. So you really got to understand what's under the hood of the overall control system. If you do have a modern control system and are interested in monitoring-based commissioning, takeaway should be that NHSaves is here to support you. We have expertise with the program, so reach out to your utility sponsor for more information. So with that, we're going to pivot to project development. How can the program help you and your customers develop projects? So the first is identifying the opportunity. Anybody can identify the opportunity. The customer, the contractor, bring those opportunities to your NHSaves sponsor. If you're not sure what the opportunities are, you can investigate a scoping study, which is a high level assessment of a building. We'll talk about that on the next slide. That's the opportunity identification stage. The next stage is you found an opportunity. Now, what do you do with it? And this is the development support. The program has streamlined approaches to where they can help incentivize projects that are fairly simple. So if it's a small control system, fairly simple sequences, there's streamlined methods that we can help develop that project. Um, or let's say you found an opportunity, you've got an older control system, tons of opportunities to put in sequences, but you're not quite sure where to go next. You can solicit a technical assistance vendor, reach out to your sponsor. They can connect you with those technical assistance vendors, and they can do what's referred to as a TA study or a focus study to really dive in and do a retrocommissioning study to identify the sequences, the opportunities, put together cost savings, et cetera. And we'll show a couple of examples of those. And then lastly is the implementing side of the project. The goal of the program is to help customers implement projects, to complete projects. So once the customer selects the scope, cost and savings are identified, then an incentive offer is put out. And then the customer can elect to implement any or all of the project. Maybe they want to only implement a piece of it because they can't afford that this year. So they're going to implement, measure one this year and measure two next year. The program is here to support customers over the long haul and establish pipeline and project development cycles. So again, NHSaves utility partners are here to support you at each of these stages. So going back to the scoping study, that's sort of the identifying energy efficiency opportunities. So these are typically offered at no cost to customers, and they are a high level assessment. So there's a high level walkthrough, typically 2 to 4 hours or so. And the idea is to just understand what's in the building, not necessarily just controls, but other opportunities as well. So you're looking to identify sort of any and all energy efficiency opportunities, or ECMs as we call them. You discuss those ECMs with the customer. It's really important that if you do a scoping study that you meet with the customer afterwards and present them the report so that they can understand A, what the scope is, they can understand what the next steps are, and they can provide feedback on what they're interested in. You identify five measures, you provide high level costs and savings, and the customer says, you know what, I'm really only interested in one and two. Okay, then we talk about how to move forward and define the next steps. The next opportunity would be a co-funded technical assistance study. So let's say that scoping study identified a retrocommissioning opportunity. Um, and the customer didn't have the in-house capability, and their controls contractor really didn't, developing savings wasn't their expertise. They wanted support. Then that customer can work with a technical assistance vendor to develop a TA study. And what that is it's basically a deep dive version of the scoping study. And it's focused on what the customer is interested in. So again, if that scoping study identified 5 opportunities, but the customer is only interested in, say, just for simplicity's sake, one of them with retrocommissioning, then you could do a focus study strictly on that retrocommissioning. And that involves a detailed energy assessment. So you can think of a TA study like a level 3 ASHRAE level audit, but really focused on the systems and the equipment of interest to the customer. These studies will partner with contractors and vendors to develop the scope. One thing that's really important in the control space is that you want to work with the customer's contractor, and that contractor has a lot of knowledge of the facility. Oftentimes, they know where the skeletons are buried, and they know what works and what doesn't. And you've got to partner with them to make sure they're on the same page. And if you're going to recommend a sequence, that they're on board with it. Because the worst thing you can do is try to jam scope down the contractor's throat, and then all of a sudden, there's conflict between the contractor, the customer, and the vendor. It really needs to be a partnership. Um, that study would then, in partnership with the contractor, develop costs. The contractor is obviously going to provide the cost to do the programming and update any hardware that's necessary. And then the TA vendor would develop the energy savings for each of those sequences or ECMs. And then one of the other benefits of a TA study is that the TA vendor will provide all the documentation necessary to the utility and support the customer to get an incentive offer. sort of takes the burden off the customer of having to navigate the program, which can be really helpful to many customers. So with that, we've laid out the project development opportunities and approach with either leveraging scoping studies for identification or TA studies for a deep dive. And again, if you don't need a TA study and you can develop savings yourself, you have an in-house energy manager that can develop energy savings, and you can just submit those projects directly to your utility sponsor through a custom application, and they can help you navigate how to get an incentive offer. So don't take the takeaway shouldn't be that you have to do a TA study. It's a resource that's available to you. So next, we want to highlight a couple of retrocommissioning case studies. So the first one here is a large electronics manufacturing facility. This company actually has an in-house sustainability team where they are capable and oftentimes do calculate their own energy savings for projects. This particular facility was a half a million square foot industrial facility with laboratories, clean rooms, testing and manufacturing areas. Um, we did perform a TA study for this one, focusing on a 28,000 square foot lab with 5 large air handlers. So here's just a single example of one of the sequences that was found. Here's a graphic of one of the air handlers. We identified several sequences of operation in partnership with the energy manager and their controls contractor. Here was an example of preheating and cooling simultaneously because just inefficient sequences and set points. They were literally running the heating coil and the cooling coil simultaneously when it was not obviously not necessary to do so. That project included 12 sequences that were identified, varying from supply air temperature reset, leaking chill water valve, airflow turn down, just literally just slowing down constant volume air handlers with cooling and reheat can be really cost effective. Balancing the airflows, knowing exactly, what airflow do you need in the space. Static pressure optimization, air handler rebalancing, economizer, making sure that your economizers are working properly and that you're benefiting from free cooling. When it's cold outside, which it is a lot in New Hampshire, you should be leveraging that cold air to provide free cooling. Outside air reduction, this is another big one where oftentimes, air handlers bring in too much outside air. And balancing the outside air to what the space actually needs and further implementing demand control ventilation can be a great opportunity. Demand control ventilation wasn't a sequence here because of the lab nature of the space, but in many spaces it can be great. And then there's a few other sequences here for these 5 air handlers. And the TA study involved putting together the costs from the contractor to do the testing and balancing, the functional performance testing, and the reprogramming. And then it included putting together the annual electric and natural gas savings. And this project received an incentive offer of just over $64,000 with an annual cost savings of over $223,000 with a simple payback of 0.6 years. So again, some controls projects can be the new lighting with very, very low paybacks. The customer, went through this project and it had a very satisfied experience and really understood the leveraging the value of the program. And now they're doing this same exercise across other air handlers in the facility. And sort of going lab by lab and making sure air handlers are balanced properly. So that's one example. And then the second example, switching over to a hospital facility. So this is a 156,000 square foot full access critical hospital, emergency department, surgical, intensive care services, typical hospital. A little smaller of a facility up north, but this was a TA study focused on retrocommissioning for the HVAC system. So one example, again, with the graphics of an air handler, you're going to see here the outside air temperature was 36 degrees, but yet the outside air damper, if I zoom in here, is only 5.7%, while the chill water valve is 35%, delivering a discharge air set point of 62. So a great example of where economizer sequence is clearly not working properly. Um, One thing that's really important with economizer too is making sure that outside air damper actuator actually works. I can't tell you how many times, again, you open up an air handler and the linkage is just dangling in the plenum because it's not hooked up or the actuator just doesn't work because it's so old. So making sure those end devices are functioning properly is really important. This is just one of the examples from this project. So again, the sequences in this project included 11 across not only just rooftops and air handlers, but also the boiler plant, the chiller plant, exhaust fans, as well as terminal units. So it included supply air temperature reset, static pressure optimization. This one included demand control because in a hospital facility, so long as it's an appropriate space, demand control can be a very good opportunity because there's a lot of varying occupancy in a hospital. Again, the economizer sequence we just pointed out. This building had exhaust fans that were just running constant. So we put in a pressure control sequence to basically run those fans to maintain a pressure. So they're not just running all the time. Schedules and setbacks, one of the first things you always want to look at is just turn stuff off when you don't need to run it. Very, very cost effective. Interlocking exhaust fans and a rooftop unit, so that when the rooftop unit doesn't run, the exhaust fan will turn off. Really simple interlock measures can be really, really beneficial. Chill water flow optimization, chill water reset on the chiller plant, as well as primary pump control and on the boiler plant. So again, just slow the primary pumps down to maintain a differential temperature. As long as you're meeting the boiler's minimum flow, it can be a great opportunity. And then one of my favorites from this one was the OR occupancy controls. So ORs have to maintain a certain air changes per hour and dew point control when the ORs are being used. It's really critical space. Um, Except when they're not occupied, they don't need to maintain those same air changes per hour and temperature and humidity requirements. So this customer, the facilities manager here was really aggressive and was able to put in occupancy controls so that when those ORs are not being used, and there's nobody in the space, they set them back from an air changes and a dew point control standpoint, and it really can save a lot of energy. Requires a lot of buy-in. You've got to work with the surgical staff and make sure everybody's on the same page. But when done properly, it can be a really great energy savings opportunity. So this customer leveraged several measures at once, which is great. You always want to sort of bundle projects together, especially if you've got some more expensive projects that have a longer payback. Leverage the retro commissioning to sort of help pay for those other measures. So this customer did lighting, they did controls, they did HVAC all at the same time. Focusing on the retro commissioning measure, we worked with the controls contractor to develop the scope and get the costs. Put together the energy savings. This facility has a wood chip boiler, so we included the wood chip savings. They received an incentive offer of just over $58,000 with a total simple payback of just under a year. This project also included a server room free cooling. They basically were able to switch their server room over to the free chilled water that they had instead of the mini splits and air handlers that they had in there previously. So that was a nice touch, as well as integrating some exhaust and server equipment that really didn't contribute a ton to the energy, but was something that the facility staff wanted to accomplish. So it was an example of just being able to leverage energy and operations under the same project and have the overall total project still have a great payback. So with that, we will open it up to questions.
Thanks, Jeremy. That was great. Really appreciate you doing that presentation. Great overview of the a typical BMS screen and control system, as well as the opportunities for retro commissioning. One thing I want to definitely echo of your sentiments talking about kind of lighting being the main item for efficiency projects in the past, where this kind of becomes the next opportunity. I think it is. I think that you gave a couple examples of some larger sites, but even smaller sites. I think if it's just one rooftop unit serving a small commercial space, likely the day that thing gets installed, stuff starts to go out of calibration, and there's opportunities there to recommission and get that working better and getting better savings for the customer. So with that, we'll take a look at some questions that have come in, and feel free to add any at the Q&A section on the bottom. But one question is, how do these projects, from a New Hampshire Saves incentive standpoint, how do these projects differ from a BMS project?
How does retro commissioning differ from
Yeah,
a BMS project? I don't think they differ a whole lot. If we're talking about what is a BMS project is like putting in a brand new BMS, what really matters is what sequences are being implemented. Doesn't matter if it's a brand new BMS or if it's a retro commissioning project. What really matters is what sequence are being implemented that are energy efficient. The only thing to consider with a brand new control system, if it's a brand new building being built, then we have to look at code being the baseline. So, for example, IECC has many controls requirements. For example, schedules, setbacks, resets, etc. That if you're building a brand new building, you have to comply with those codes. So those may or may not be eligible. But aside from the code impacts, really any controls project is eligible as long as the sequences are saving energy.
that's a good point, and it makes me think of a follow-up question for that. If you're adding a new BMS onto existing hardware, where the code requirement might have a demand control ventilation requirement, but you might not have that hardware that's already in the system that's able to provide that. How does that get looked at from a BMS install?
So if you have an existing building, you're not doing a major renovation, and you have existing let's say air handlers serving a space, that project would not invoke code because you're not doing a major renovation that's going to result in having to bring that space up to code. Therefore, what really matters is the existing controls. Do you have existing um, demand control ventilation? If the answer is no, then that would be a great opportunity. But then also with that comes what is the existing outside airflow, right? Many customers have elevated their airflows as a result of COVID, whereas some customers have minimized their airflow because they saw the impacts of COVID and then they turned it back down. And so there's been examples where you go in and the outside air dampers are only at 5%, despite, typically they're at 20%. So the existing conditions then become the baseline of what we would look at for energy efficiency improvements.
Great, thank you. Question came in asking if we have a qualified TA vendor list, and I think this is somewhat related to a new offering that we have in the Massachusetts NHSaves program for an existing building commissioning program, where we have slightly different type of offering, where there's what we called a qualified QSP, qualified something provider.
Service provider.
Thank you, Jeremy. So we do have a pre-qualification process there in Massachusetts. The idea is that a customer could then bring a commissioning project to the program, and they could just pick from a list. We do not have that in New Hampshire. We're talking about definitely putting more emphasis on HVAC systems and commissioning in our next 3-year plan. However, we do not have a priority TA vendor list for that. So anybody can bring that a project to us as long as there's energy savings opportunities. But it does bring up a good question that I have for you, Jeremy, which we see this in some cases, and you mentioned in your presentation about fault detection systems that are out there, as well as other kind of software systems that sit on top of an existing BMS that might find things that are wasting energy. Typically, larger sites might have a subcontracted vendor for their control system. How does that work with bringing a new project into New Hampshire Saves if they're an existing, kind of developing their own scope, if you will, for the recommissioning process?
So if a contractor is developing their own scope?
Essentially, right. They're already on site and they're bringing a retro commissioning project to the table.
Yeah, so absolutely. If that contractor is able to put energy savings calculations with that scope, then they can simply submit a custom application to their utility partner, include those energy savings calculations, and then they'll get reviewed internally by whoever the utility partner is, and an incentive offer would be um, developed from those energy savings and that scope of work. If that contractor doesn't have the capability or interest in putting together the energy savings, then that's a good opportunity to partner with a TA vendor and have the TA vendor just take the scope of work and then put the energy savings together with that.
Great. So I think we're at time. I have one last question I want to throw in there because I think it's important for folks that have projects coming up. But a demand response. So there is a demand response program in NHSaves. When you're looking at these commissioning studies and you're talking about new control sequences, it's an opportunity to maybe carve out something that the customer could do to bring demand response to the table and enroll in our Connected Solutions program. So just something to think about if you're doing this type of work that is going out there. We have other questions coming in, but I do have to end now, but we will make sure to answer those questions and get it back out to you. So Jeremy, really appreciate your time and your presentation today. And I hope folks enjoyed the session, and we look forward to working with you in the future. Thanks a lot.
Thank you.